All right, everybody, so welcome back. I'm going to do our next um, example here. Okay, so let's first dig into what we are looking at. So let's see if I can do this. All right, so now we are looking at a firework projectile. Okay, so we're saying during a fireworks display, a shell is shot into the air with an initial speed V naught equals 70. Let me just kind of, there we go. 70 meters per second. At an angle, we're going to say theta naught equals 75.0 degrees. Okay, and it's illustrated in this image here. The fuse is timed to ignite the shell just as it reaches the highest point. So we're going to call that point. Okay. We want to calculate the height at which the shell explodes. We want to know how much time has passed between that launch and the explosion. And what is the horizontal displacement when that shell explodes? Okay, so let's break this down. So for our first one, we want to know our maximum height there. Okay, so that would be our Y final. Okay, so this is what we're looking for. Okay, so what we'll do is we'll start looking at our situation here. So at this highest point, we can start thinking about what our velocities would be. Okay, if we have gravity involved, which we do. Okay, and anything like that. So let us claim that our starting position is at y equals 0 and at x equals 0. Okay, so those are our initial positions from where this is launched. Okay, and at this peak here, remember with free fall, okay, when a ball gets thrown in the air and then it comes back down, okay, at that peak point, which is the exact same idea here, our velocity in the y direction is 0, okay, because the ball is going up, then it slows down to a stop, and then it falls back down. So our velocity, our Vy at that maximum point is 0, okay? Now, what about our initial velocity in the y direction, V naught y? Okay, that is going to be, just like we did in the previous problem, our V naught times our, this one's going to be our sine of theta naught, okay? So it's going to be just like our last one here, okay? So now we have our y directions kind of down. What about our x directions? Because I know that at some point we're going to need those too. Okay, so let's just keep going here. So at our initial launch, we get some x component. So v naught x, it's going to be similar. V naught times cosine theta naught. Okay, and if you remember from here, our velocity is constant the entire way in that horizontal direction, in that x direction. Okay, so this is also going to be equal to x at that highest point. Okay, so now that we have a lot of information for us, we can try to determine that max height. So what equation are we going to use for this? Oops. Trying to move this over. Okay, well, what do we have? So we are looking for our y. So that's in this equation and in this equation and in this equation. Okay, we have our v sub y. So that's in that one. It's also in this one. Or I'm sorry, right here. No, v sub y, I'm sorry. V sub y right here. Okay, we have our v sub naught y. right here, there. We don't have a time, so we can't have a time in here. So I'm going to say we can use this equation right here, so this bottom one, okay? So, trying to move this over, but it does not want to do it. There we go. Okay, so we're going to use this bottom equation. So let me write it out. Vy squared equals v naught y squared minus 2gy minus y naught. Okay? So, excuse me. So, my Vy at that peak is 0. So, boom, that's gone. Okay? Now, my starting point of y is also 0. Boom, gone. Okay? So now I just have to plug in a couple more things, right? Okay. So I want to solve for y. So what I'm going to do is I'm going to add this piece to the other side. So doing some algebra, 2gy equals v naught y squared. Okay. Or y equals v naught y squared over 2g. Okay. So now I will plug everything in. My v naught y is v naught sine theta naught, and this is squared, divided by 2g. Okay, now I can plug things in. My v naught was 70 meters per second, so 70 meters per second. And my theta naught is 75, so times sine 75 degrees squared over 2 times 9.8 meters per second squared. Okay, plug that into your calculator. So 70 times sine of 75, then square that value, divided by 2 times 9.8. And we get my maximum height as 233 meters. So again, that equals y. Okay? So our height here that it travels, this total height is now 233 meters. Okay? All right, so hang tight and then we will get on to part B. Okay, so let's move on to part B. We are looking for how much time passed between the time of the launch and the time of the explosion. Okay, so we now have y. Okay, so we know y. We know y naught. We know v naught y and v y. Okay, so let me use this equation here. Okay, so I can use this equation to solve for my time. Okay, and matter of fact, let me see here. I can actually use, yeah, that's the one I'm going to use. Okay, I was just making sure that's the one that I used in my notes. That's the one that makes the most sense to me. Okay, so part B, part B, I'm looking for time. And again, I'm going to use this one here. So y equals y naught plus 1/2 v naught y plus vy times t. Okay? So I like to do the little algebra stuff first before plugging in numbers. It just helps me. If you'd prefer to do the other way, it's up to you. Okay, so I'm going to do a bit of algebra. And since I know that my vy is 0, Okay, remember from up here, my Vy is 0, and my Y naught is 0, my initial. I can simply solve for my t. So my t is now going to be 2 times y divided by V naught y. Okay? Now, plugging in my numbers, my y, remember, was 233 meters, I believe. Yes, 233 meters. Okay. Divided by my V naught y, which is V naught. Okay, and that was 70 meters per second times sine of 75 degrees. Okay? So now, use my calculator. 2 times 233. Divide that by 70 times sine of 75. Okay, and we get 6.89 seconds. Okay? So this is the amount of time that it took for the shell to be launched to when the shell explodes up at that peak. Okay? All right, so last one is part C, and we want to know our horizontal displacement now. Okay? So I'm going to look over here at my equations and I say, okay, well, I know my x0 is 0. Okay. I know my t, and I can solve for my v sub x because my v sub x is here. It's related to my v naught. Okay. So let me go over here and I'll say part C. Okay. All right. So I'm going to use this equation. X equals x naught plus vxt. Okay. My x naught is 0. Okay. Now I can plug in my vx as v naught times cosine theta naught times t. Okay. My v naught was 70 meters per second. Okay. My cosine, or my theta naught, I'm sorry, is 75 degrees. And my time now, since I just solved for that, is 6.89 seconds. 6.89 seconds. Okay. Now, again, using my calculator. Calculators are your best friends right now. 70 times cosine of 75 degrees times 6.89. That comes out to 125 meters approximately. Okay. So now my horizontal component is 125 meters. Okay. All right, so I know that that was a lot, but these are the types of problems that you guys will be doing, okay? So I'm trying to get you guys comfortable with these formulas and how to set it up and solve the problems. Okay, so I will have one more example for you guys in the next video.